the question. Suppose a new function is defined as f1, which has got the same rule as f, but a different domain of -1 to 0. What are the points of intersections of f1 and f1 inverse? Can we still use the rule that f1x equal to x gives us intersections? In this case, no, because f1 is not increasing. In particular, we can draw the graph of f1 to see what's going on. f1 has a turning point here, crosses the x-axis somewhere here, which is actually on -1 to 0, goes up like this. Now, the inverse of this function will be a reflection in the line y equal to x, which will now start here and go up. Now, let's work through the algebra to determine the inverse function. We would say let y inverse equal to f inverse of x such that f of y inverse is x. Now substitute y inverse into the rule of f, which is y inverse squared -1 equal to x. Rearrange this to give us y inverse squared -1 minus x equal to 0. We shall now apply the quadratic formula to obtain that y inverse equals to. Now we have found that y inverse is equal to ±1 plus x. Now there's two branches. Which branch is it? There's two ways to think about it. First one is to consider the domain. We note that the range of f is the domain of f inverse, and the domain and the range of f inverse is equal to the domain of f, which in this case is -1 to 0. So quite obviously we should pick the minus or the negative branch. This will be sufficient for justification. Or alternatively, think about a point on f. 0, well, let's take -1, 0 is on x fx. So 0 minus 1 is on x f inverse. So again, the negative indicates that we take the negative branch. Now we can solve for the intersections. Of course, this is a bunch of work. We can do it, but in this case, there's actually another trick which we can use. Again, consider the graph of f. In this case, the inverse will be looking like something like this, where this is the original function. In other words, we can see that the intersections are on the line y equals to -x minus 1. Or, quite obviously, there's one point on y equal to x, and then another 2 points are just the endpoints. So let's solve this question using this trick. So that's just giving us 0 and -1, which correspond to the points 0, -1, and -1, 0, as expected. Whereas the other point, the midpoint, will be essentially the negative branch of x squared plus 1 minus 1 equal to x. In this case, we'll be getting x squared minus x minus 1 equal to 0, and x equals to taking the minus branch yields the solution. So the set of intersections are these 3 points. To be safe, for a general question, if the function is not increasing, you should always be using the full equation. However, there might be symmetries that can be utilized, such as this particular one, to significantly simplify the algebra. But you should think intuitively and algebraically to check that you've got the right solutions.